Okay, here is another example. In this question he's asking about find the current passing through the load RL. Okay, first thing, is it an inverting amplifier or non-inverting amplifier? Inverting is nothing but you're going to give your input to the negative terminal. Non-inverting is nothing but you're going to give your input to the positive terminal. So this is a non-inverting amplifier since I'm giving input to the non-inverting terminal. We always take this value as V2 and the voltage at this point as V1. So what is V2? V2 is 4 volts, and we always know V2 is same as V1, so I know V1 equal to V1 is also 4 volt. Now at V1 apply KCL. Okay, if apply KCL at V1, we know that there is no current going in. I'm going to choose this as IF and I1. Both currents are going out. IF plus I1 equal to 0. It's up to you. You can choose any direction. Or KCL is nothing but currents going out must be equals to currents coming in. So here I'm choosing both currents are going out. So IF plus I1 equal to 0. Is it possible to have every current going out of the junction? No, at the end for sure we will end up finding at least one of them is going to be negative current. Okay, so IF is nothing but V1 minus V0. So the voltage at this point is V0 over 40k plus I1 is nothing but V1 minus 0 over 20k equal to 0. To eliminate the denominator, I'm going to multiply with 40k. So V1 minus V0 plus 2V1 equal to 0. So 3V1 minus V0 equal to 0, or I would say V0 equal to 3V1. See, since our input is given to the non-inverting terminal, your output is a positive number. So 3 times 4 V1 equal to 4, that's a 12 volt. So what is IL in this case? IL equal to V0 over RL. So 12 over 10k, 1.2 milliampere. That's the load current. Okay, I'm going to solve another example in the same video. Okay, I just want to go back to the same question here. The first thing, see, this is grounded here, this is grounded there, this is grounded here. So don't get confused if all these three are connected, okay, and grounded at one point. It's the same circuit, even though, so ground is connected everywhere. So instead of having 3 grounds, I can have a single ground by connecting them together. Okay, here is the next example. In this example, he's asking us to find Ix as well as V0. Okay, is it inverting or non-inverting? Since our input is connected to the positive terminal, so for sure this is a non-inverting amplifier. Now as usual, I'm going to take this voltage as V2, okay, and this voltage here as V1. Okay, now V1 and V0 are short circuited, so can I say my V1 and V2 equal to V0? Okay, which I don't know what is V0 in this case. Okay, so the voltage at this point is V2. Now let me choose this node as Vx. Okay, node here is Vx. At Vx apply KCL. At Vx apply KCL. So if I apply KCL, this current is coming in, I'm going to choose every current is going out. Okay, and I'm going to label them I1, I2, I3. Okay, so 4 milliamperes is coming in, that must be equal to I1 plus I2 plus I3. Now what is I1, can I write this as Vx over 3k? I2 as Vx minus, so V2, can I write V2 as V naught? Let me put this V2 over 6k. I3 equal to Vx minus V naught over 12k. Okay, so this is 4 milliampere, and as I mentioned, I know V2 equal to V naught, so I'm going to replace that V2 with V naught, and at the same time I'm going to multiply this with 3k, multiply this with 12k, plus Vx minus V naught over 6k plus Vx minus V naught over 12k. So I'm going to multiply this with 12k. I will end up with 48 equal to 4Vx plus 2Vx plus 2V naught plus Vx minus V naught. So we'll end up with 7Vx plus V naught equal to 48. This is my equation 1. Now I have two unknowns, so I need to come up with the second equation. My second equation is going to be, I'm going to apply KCL at V2. So at V2, apply KCL. Okay, so if I apply KCL, I'm assuming this current is I2 and Ix is going out. What is the current going in there? That must be 0. So at V2, apply KCL. So I2 equal to Ix, basically here I2 equal to Ix. What is my I2? I2 equal to Vx minus V2 over 6k equal to Ix is nothing but V2 over 6k. Okay, so basically I can say, multiply this with 6k, so Vx equal to 2V2 if I take to the other side. So this is nothing but 2V naught. So Vx equal to 2V naught. That's good. Now this is my second equation. Now I'm going to substitute my second equation in the first. So I will end up with 7Vx. So I'm going to substitute Vx. Instead of Vx, I'm going to substitute 2V naught plus V naught equal to 48. So 14 plus 15 V naught equal to 48. V naught is nothing but 48 over 15 volt. Okay, so that's our V naught. Now Ix, to find Ix, substitute this in the equation 2. So I'll end up with Vx equal to 2 times 48 over 15. Now our Ix must be Vx over 6k, so that must be 2 times 48 over 15 divided by 6, so 12 over 15 milliampere. That's our Ix. Okay, I'll stop this video here. I will solve more examples in the next video. Thank you.